Good afternoon, everyone, or depending where you are, good evening, good morning. Welcome to this presentation of the end-to-end solution for sheet metal fabrication. My name is Olaf Kerner, your host for today. I've been with sheet metal and Radband for a good 25 years now. Some of you may know me. If so, welcome back. If not, I will be presenting the end-to-end solution for sheet metal fabrication to you this afternoon. I'll be taking about an hour of your time today, and I hope you find it interesting. So what are we going to go through today? First of all, I'll explain to you who we're aiming this at, who should be listening to this and who should not be. Then we'll look at the business challenges that we find as Hexagon in the sheet metal world. And then we'll show you how we are addressing these issues, or trying to address these issues using our product portfolio at Hexagon here. Then we'll do a quick recap over the actual products that you've seen in that end-to-end solution. And we'll talk through some of the key benefits that you'll gain from this solution. So, who is this aimed at? Who are we looking for in the market when we talk about sheet metal fabrication? Just check. I think there's a message coming in. Okay. Who are we talking to? Hope you can all hear me, by the way. I'm just checking whether there's any messages coming in. It's looking good. Okay. So lots of our customers are in, for example, industrial equipment, such as kitchenware, air conditioning, air cooling and heating, general electronics enclosures, for example. Okay, we're aiming for those. Another large group that we find is agricultural equipment and automotive. Okay, there's a big group of our customers in that area. Aerospace, of course, medical equipment, oil and gas, and then not to forget anybody who's subcontracting in any of those areas, we're looking after as well with our end-to-end solution. Okay, so quite a broad spectrum, but they're basically combining sheet metal or tube parts into assemblies and finished products. That's who we are trying to serve. So when we look at this manufacturing world, the sheet metal fabrication, we see all these business challenges coming up. Okay, we all face shortened lead time. We try to reduce prototypes. We try to eliminate manual operations and free up human resources through automation. Try to reduce rework, so increase the quality or make sure that the quality is predictable and consistent. We try to capture a lot of the skills into our software from the people, so that this skill can be transferred successfully to other members of staff. And also we see that in the sheet metal world, people have to really respond to changes very, very quickly. Okay, and all our solutions are trying to address these challenges and help businesses with these challenges. Okay, and in the sheet metal world, these challenges come up in different forms. So we try to listen to what you're dealing with, what you're trying to deal with, and come up with solutions that genuinely help. So when we talk about this end-to-end solution, we have the following in mind. Okay, we're not just a CAM system trying to run your machine. Of course, that's where we come from. That's where we have a large and big experience. But we're trying to capture more of your workflow and help connecting those workflows together. So when we talk about the end-to-end solution for sheet metal fabrication, we do include the first moment a project comes into the company. That could be a phone call, it could be an email with some 3D files or 2D files and a description. Okay, but something enters into your company, and we use WORKPLAN to capture that information. Who sent it to me? What if they sent me? Did they send any geometry, any files, any indication of a lead time, any quantities, any particular material requirements, anything that's useful to capture at that early stage we're trying to capture in WORKPLAN. Okay, just to make a record of what's happening. And then we start preparing for manufacturing. Now, the initial preparation is to see what the customer's actually sent us. Okay, has he sent us DXF files, DWG files, step files? What have we got, and can we do anything useful with them? We try to analyze that as quickly as possible using our product called Designer. Okay, just to get to see whether we need to ask the customer for more questions or whether we can actually make a judgment on whether we can do the job. Whether we can do the job is one question, but the next question your customer will ask you is, how much will it cost? So then we go to a cost estimation and quoting stage using a product called RadQuote. Now, hopefully by that time you've then won the order, and then it's time for you to figure out how exactly these parts, this assembly, whatever came in, is going to be manufactured. And actually this is an opportunity for you to optimize what you've got. For example, you might make slight modifications to the design so that you can reduce welding, for example, or make sure that you can manufacture it in one piece rather than two, or different changes. Okay, so that's why we call this part manufacturing optimization, and that's why we're back in Designer, and it has really strong functionality to help with that. Then in our workflow, we try to solve the bending question first in sheet metal. Okay, because bending is quite an art. You have to know how the material behaves. You have to figure out a sequence, check whether you have the tools for this, and if any of those cause a problem, we need to go back to the design somehow, or back to the customer even. And preferably, we want to do that before any cutting happens on the laser machines or on the punching machines. Okay, so that's why we program the part for bending first, so we know all these things. And then also we know what 2D shape we need to cut. And then we can program and prepare the part for cutting as well. And I'm calling this programming or preparing because this isn't the moment where we start cutting yet. Okay, we're hoping for more orders to come in so that we can later combine them. But the top workflow that we're showing here is something that comes in and repeats hopefully all day long, waiting for orders to come in. And then at some point, we're going down to the next part of the workflow, is where we do planning and scheduling. So at some point, somebody has to make a decision. Okay, now we've waited for enough orders to come in. Let's start producing and cutting some of these parts. And that's where we're back in WORKPLAN to plan and schedule the next operations. Okay, and also in WORKPLAN, we manage the materials, so the stock levels, but we also can predict stock levels based on the orders that are in the system. Okay, and we do that before we start nesting and cutting and sending things to the CAM system. After everything's happened, hopefully successfully, all the parts have been inspected and accounted for, we can then dispatch and invoice back in WORKPLAN. So those are really, we're depicting it as one workflow, but there's potentially a break between the programming of single parts and then the planning. Okay, there might be a couple of hours between them. Some companies have a few days between those stages where they prepare the production later. Okay, but in essence, this is the WORKPLAN, the workflow that we're trying to look after. Now, over the next slides, what I'll do is we'll talk through those initial those stages, and I have little videos showing you how we do this in our software. So, Project Enquiry. This is like I described earlier. We receive something. I don't know. It's a phone call or an email, hopefully, with some geometry, even more hopefully, and any indication about materials, quantities, any constraints. Yeah, maybe the material has to be absolutely scratch-free, or anything that the customer has told us. And and including anything about the due date that he is expecting. All that is information that we need to capture. And we do that as soon as possible inside WORKPLAN, so that everybody in the organization automatically knows that this work has come in. Okay, we haven't analyzed it yet, but somebody is talking to this customer and working on it. And this is a video of what this looks like. So this is where the project inquiry comes in. So we're starting up the WORKPLAN software and logging in. And then we create a project structure. And the most important thing here is choosing the customer we're doing this for. Okay, it might be a new customer, an existing customer, it doesn't really matter. Okay, and maybe the customer's given us a reference number that we could use and refer to. And we're going to take those and we're going to assign people to look after this project. Sales manager, we check this shipping address, or if necessary, update it. And any comments that we can add. So maybe the customer has indicated something about the project that we didn't know about. Anything that helps, we attach. Any PDF files, any files that have been sent, any images that will help us recognize this project. We add these, and we can customize these fields as well. If there's anything that's important to you to track during the run of this project, then we can capture that. Okay, so we're quite flexible. It's a database system that can be configured to suit you. Okay, so that means we now have a project on our hands, and we've captured all the information in WORKPLAN, and we can continue. We can investigate and see whether this project is worth pursuing for us. And that's what we do in Designer. We try to graphically view this project, and in this case, in the screenshot, you see a single part, but it could be a large assembly, medium assembly, an assembly with sheet metal parts, but also with tubes or any screws fixing. It doesn't really matter what's in there, but we want to have a look inside Designer to see what the customer sent us, to see whether we need to ask additional questions. That's what we call preparation for manufacturing. Do we have, in theory, the information that we need to produce? Okay, and in this case, we've made an assembly with a hopper and a tower, tubes, there's plates, there's fixings in this assembly. And Designer is really good at tidying up and analyzing the structure of this assembly. Okay, so even if I have to manually change some of it, I can very quickly focus and create sub-assembly, so to speak, in Designer to help me manage the information in here. Okay, what I'm going to do here in the example now is just focus on some of the sheet metal items and make sure that they've been designed properly, that I can unfold them, etc. Just to eliminate any problems very early on. Remember, this is just at the inquiry stage. We haven't told the customer that we're going to do it. We haven't told them how much we're going to charge them. This is just investigating whether we have something on our hands that we can work with. And that includes the materials. Okay, we need to look at these parts and with their material information and see, okay, we can make this material, or maybe it's too thick, or maybe we've never cut this material. Okay, we need to know this up front before we tell the customer, A, whether we can make this assembly for them, or B, even how much it's going to cost them. Okay, and that's what this stage is about, just indicating and showing and checking what we've received. And the more the customer puts in, so if he sends us a SolidWorks file or a step file with all the materials set, then we will use that. Okay, and if we've set up the Designer system in such a way that matches what the customer uses, or roughly matches, then we can automate all these steps. Okay, and then this step is just a button click away, and it gives us any messages about problems that we might have. Okay, so this is just a check of some of the parts, just to see whether they unfold correctly. because these cones are usually the difficult ones to work with. Okay, and when we're happy enough in this assembly, we can then send the data into Radquote. And Radquote is the system where it's just going to have a good look at these parts and see what it will take to make these. Okay. Radquote is made for sheet metal. It handles tubes as well, and it can work with consumables. It can work with manual parts, etc., and any operations that have to do with sheet metal fabrication, welding, inserts, etc. So Radquote is really focused on the sheet metal world, and you will recognize that when you use the system. And there's some important work that happens here in quoting. Because not only do we get a graphical bill of materials, we also get a bill of work. And what I mean by that is that the assembly is being analyzed. All the sheet metal parts know that we have to get material for them, we have to cut them, we have to bend them. Okay, that's the sequence for these single sheet metal parts. And that means that the software can calculate cycle times, for example, or handling times, material costs fully automatically. You can see that it's actually trying to nest these parts together to calculate the best sheet size to use to get a competitive quote out to your customer. It's very important because we can get an accurate cost or a high cost and never get the order, but it's important that we get a competitive cost. Now, the other things that happen in here, tubes are not alien to Radquote either. We can add all the tubes in here. The operations may be different, but we still need to buy material. Okay, and to calculate the material cost, we use the same nester so that the process is exactly the same whether you use sheet metal, flat parts, or tube parts. Now, another thing that happens in Radquote is that we further try to analyze where the cost is going. Okay, so we might be able to optimize and reduce the price by having a really good look at where the costs are. Okay, it might be in the cutting. So maybe if we buy assembly as well. Assembly itself, for example, spot actually restructured to So, sorry, I lost the sound, I think. I'm back. If anybody can send me a message that I'm back, that would be greatly appreciated. I'm back. Thank you, Gavin. So, what is happening here is that Radquote actually understands the assembly and all the operations that go into putting this assembly together. Okay, and it's not just the parts to be made, but also the assembly and the delivery and everything that goes into getting this assembly, or I think I've ordered 15 of them, to get to our customer. Okay, everything included, including shipment. And that goes back into WORKPLAN. Okay, and that's important because WORKPLAN also needs to plan in the welders, the materials, the shipment even. So everything goes back to WORKPLAN, and that's how it all hangs together. So, like I said, hopefully by this time we've worked in Radquote, we've given the customer our best price, and we may have negotiated here and there, and the customer has placed the order. And now it's up to us to make sure that we make as much money out of this as possible. Okay? And we go back to designer and see if we can optimize, tweak the parts in such a way that they are manufactured in the best possible way. And it could be a simple way of just slightly changing the bend radii so I can use standard tools, for example. Or it might be deciding that, well, if we make these two parts out of one part, we can actually save welding time and polishing, grinding, and everything else. So it's important that we go over this again and make sure that we get the best out of our sheet metal design. That's what's happening in this video in Designer again, is where we have a look at the 3D parts in a different close-up and see if we can improve anything or whether anything needs to be changed for manufacture. Okay, it's just checking whether we can do anything about that form, whether these faces are in the right place. But what I'm going to do here is have a good look at the bend radii, for example, or at the form first, I think. Yeah, form first. So that's a form, we know that, that's fair. And Designer can handle many file formats, SolidWorks, Solid Edge, you name them, we read them. And they're all, you can all immediately work with them, and that's very attractive. Now, Designer won't actually continue if you don't have the material or thickness available. So it's another check whether we can promise the customer that we will do this. Okay, and then for unfolding, we can specify. You probably know about this, a K factor, for example. But if you want, and all you know is that we're going to use the 10mm V for the bend, it's also fine. You can tell us, and then we will calculate, for example, the K factor from that. But we will also check that the radius is roughly what you thought it would be. Okay, so in this case, the radius was designed as 1.5, but with an 8mm V, I'm going to get a radius of 1.9. Now for me, creating a 1.9 radius is perfect because I don't need to buy extra tools, but I should really ask the customer quickly and see if that's still okay. So that's where we can see whether what we're expecting to get is actually real, okay, without involving a press brake as such. Okay, we haven't configured any tools in this system just yet. This is just verifying whether we can actually make this. Okay, and then to have another look at that big assembly, we can do the same thing in assembly. It's very simple. We just look at and isolate, in effect, a single part. Very quick. Just select the part. You can focus on it, and you can actually, even though this was important, I think this was a step file. You can make minor changes. For example, this corner here, I could see that would be a nightmare to weld shut. Okay, it's very easy inside Designer to change that corner. Just by modifying it, we could choose a different overlap, tidy it up completely, and that's now a lot easier to weld on the inside and keep tidy. So even though it wasn't a model that we made in Designer, we can easily change it. It's extremely powerful and quick. And we can create the new unfolding after. So it could be very worthwhile to just check the designs and optimize them just like that. And also, if the customer did phone up and said, "Oh, I've changed my mind about these corners," it's very easy to change them inside Designer. Reacting to changes is very quick. So and then I would say that part is now ready for manufacturing. Okay, we may have made a quote for it, and now we've got it ready the way we want to make it and the way we can make money on producing this part. If you haven't already, I can recommend looking at Designer. Actually, it's a fresh new approach of as a tool, as a design tool for manufacturing, especially in sheet metal. We're very pleased with it. So from the assemblies that we've just seen, we're going to prepare and make sure that we can really bend it, so that we're sure that we don't need to buy any tools, or maybe we do buy any tools, but we do that beforehand. Make sure that there's a sequence that's valid, and just make sure that everything's in place for the press brake. And the nice thing of doing this without inside Radband is what we're showing here, is that you don't have to stop the machine to do this. You can actually prove it out inside a bit of software, tweak the design if necessary, try again in Radband to see if you can find a sequence. Because it'd be really annoying if you've cut 100 of these panels, and they're quite large, and then find out that these flanges are actually too small, too short. So it'd be really good to find that out as early as possible. So inside Radband, what we do is we choose a machine tool, we choose a sequence, calculate a sequence, taking the tools into account, the tool database. We calculate the tool stations that we might need. And we place the finger stops, even if it's clamping finger stops with multiple faces, we place them automatically if we can. And the best thing about the Radband software here is a full simulation. And what it does, it checks collisions with any part of the machine, or actually anything that you model in here. It could be the controller, it could be the lifting arms, it could be anything that you can see. We simulate to make sure that this process is going to work. Okay, and we prepare not just the NC program for the machine tool, but also the documentation for the operator. So in theory, this is enough actually to run the machine tool. Okay, you don't strictly need a post-processor. You could set these up with the values shown in the report, set up the machine tool, and you know it's going to work without disturbing the press brake or cutting any prototype parts for that matter. Okay, all in software. So, but the same thing might apply for cutting. Okay, we've just prepared it and checked it for bending, but we might want to have a good look at it from a cutting point of view. Okay, and we do that in the Radcombi or the RadTube software just to prepare. So, for example, in this little video, what I've done is I've taken one of those large side panels, and maybe the customer's indicated where he wanted the lead in. Okay? Or we have a sequence in mind that reduces the heat really well, so we can manipulate that as we wish. Or maybe the customer, or maybe because of the finger stops, we don't want the lead in on the long edge, we want them on the short edge. Okay, so that we don't have to have any positioning problems. Okay, so that's for profiling. We don't have to do all that, but we can add information. And for this Amada automated machine, for example, we choose the tools that we're going to use. Maybe we'll choose micro joints, but in this case, what we do is we use the part picker on the machine. Okay, we just specify where the arms should go, make sure that the key suckers are active and on material, find a good spot to lift out this part. Now in tubes, we have other ways of preparing the parts. The same things apply, heat buildup and sequencing and collision checking. But what I'm going to do here in this little video is add what we call tenons, because this ladder needs to be put together by somebody in the end. And these tenons help greatly to make sure that we do this in the right way. So the tenon and the hole is marked with a little A. That means that the person assembling the ladder later can only put the ladder together in one way. It's just little things that we can do to make sure that we have this fabrication process under control and do it as well as we possibly can. Okay, so by using a A on one side and B on the other side, there aren't many ways we can get this wrong anymore. Okay, you also notice that hopefully you notice that I put them on asymmetrically. So there literally is only one way to put this ladder together later, which will help. Okay, and also these tenons are quite handy because they reduce the requirement for fixtures whilst you're welding it together. You can all stick it together and then tack weld them and get the assembly in one structure. And also here, we're going to have a look and see how this is going to be cut off. Okay, because cutting off non-circular tubes isn't always obvious because the thickness changes and everything. And we can simulate the whole process, the entire process on the machine, just to make sure that everything works properly. Okay, so again, this is just proving out and deciding and optimizing how this part will be made. Okay, you saw me not even talk about how many we're going to make, for example. There's no nesting, etc. Nothing's happened yet. It's just deciding how best to make these parts. Okay, we're still in that top banner of the workflow, so to speak. Like I said, hopefully that's been happening all day. You know, orders have been coming in, requests have been coming in, you've been detailing and optimizing these parts, and at some point somebody in the planning and scheduling department will say, okay, it's time to do some cutting, otherwise these parts are going to be late. Now the nice thing about doing it late is that you might be able to combine orders really nicely, okay, and therefore optimize your material. So WORKPLAN is an ideal planning and scheduling tool to do this in. So that's what we're going to have a look at. So we're back in planning and scheduling, back in WORKPLAN. There we see all the open orders. Now we're going to focus on the hopper and tower because it's quite a large job with a large quantity. But we can specify the exact workflow even further and see all the dependencies as well. Okay, there's no point cutting half of the panels and then trying to assemble it. Yeah, or we could assemble the ladder completely and the frame completely without cutting any sheet metal parts. Okay, so that's what's happening here. We're literally loading it up into a Gantt chart and running the scheduler and try to simulate the job and try to predict what's going to happen. You can see in red some of the orders might become at risk, so to speak. Okay, so it's a very useful tool to see that up front. See per resource, whether that's a machine or a team of welders or a team of assembly people, we can see exactly what their workload is. You can see their daily plan. Okay, we can output that as Excel files, or we can share that in other ways, and we can see exactly how busy certain teams or resources are going to be during the day. Make sure that the schedule fits. So once this schedule, this plan has been made, we now need to look at our raw materials and see which process, which flow fits best. Okay, so before we launch an order into production, we need to make sure that we have the material. And WORKPLAN has a useful tool in place to predict how much material we need. Okay, and because WORKPLAN is a manufacturing execution system, placing an order for materials that you don't have or running low of is inside the same system. Okay, so any projects that are ready for production can run the sheet metal requirements estimation. So anything that we've released, can have a look. And it's using the Radm Nester in the background to try and predict how much material we'll need per material and thickness. And if not, Radm will tell us which sheets we'll need to buy. And creating a purchase order inside WORKPLAN is literally no more difficult than dragging the material requirement onto the purchase orders, print off the purchase order and send it. You can actually email it straight from WORKPLAN to your supplier. Okay, now we know that the WORKPLAN has made sure that we have enough work for the day, for the machine tool, for the resource. We have the materials in stock, And this is where we now start doing the technical CAM side, so to speak. Okay, it's where we do the nesting in effect. So what WORKPLAN will do is we will prepare a list of work for us to do. Okay? And it's we can choose how this comes together. So in this case, loading up our hopper, Radon automatically extracts all the sheet metal parts, set an overall quantity, see how many we're making. There we go. All the parts end up in our nesting environment. Now, how these parts end up here varies greatly per company. WORKPLAN can send them. You can add them manually. You can add them using different links to MRP systems. It's very flexible. Okay, but with WORKPLAN, you get not only the part requirements, but also the available materials and sheets. Everything is then followed through. And in the Nest project, what you see up front here, you will also see the order numbers, the customer names that you're making these parts for. And using our nesting algorithm, Radon will very quickly work through all the parts that are required and calculate which sheet sizes and what nests we need. Actually, for this Mazak Optiplex, I've optimized it such a way that everything's happened automatically. It actually outputs the NC programs ready for the machine tool, so full automation was switched off. It automatically scraps remnants or cuts remnants apart, stores them for later, calculates an overall runtime. Okay, and this is generally what goes to the production floor. And in this case, what we see is that the NC programs already landed at on the shop floor, together with any setup information for the machine operator. So the NC programs for the machines and PDF files for the machine operator, so he knows exactly what he's cutting, how many off, who they're for, etc. And we're using color coding to identify them. Now, well, that was for sheet metal flat parts, but for tubes, it's a very similar workflow. Okay, we open the hopper, so to speak. Okay, and then it's RadTube who analyzes the tubes that are required. Okay, what shapes they are, what lengths, what materials, which go together. It disassembles them into individual items and parts. Okay, for every shape that it finds, it asks me a quick question about what strategy I want to use for cutting, so we can increase the automation. But the assembly is disassembled completely autonomously. With the automatic shape recognition, we can be sure that only the tubes that belong together are nested together. We are. Okay, so that's the part requirements. Again, we see all the order numbers and customer names against the part if we need to. We get all the stock, so the raw material shapes and sizes into the system. And the nester very quickly works out which parts should go on which tube together. Very powerful nesting algorithm. Again, to make sure we make the most of our material. I've always said it's the same requirements as flat sheet metal. So using similar algorithms makes sense. We get a good overview of what materials are required. We can actually automatically imprint or write information onto the tubes as well. Like I said, with the tenants already, but we can also put order numbers or customer names onto the tubes, so we know who they're going to be for, which will help later downstream. Similar to in 2D, we've prepared the NC programs and the setup sheets for the operator in the background, so they have everything they need to run our production. individual nest jobs that have been created. Okay. Let's optimize the cutting sequence to make sure that that the handling in the machine is done properly, that the material, the heat buildup is under control, and everything else, everything's happened automatically in the background. At any point, I'm free to have a look at the results simulated with the entire machine tool. No issues with that, but RadTube and Radm CAD/CAM, they both offer huge level of automation. So a work plan is actually keeping track of all our activities. Okay, everything that a machine or a person actually does. Okay, we can install touch screens, barcode readers, time cards all across the company just to keep an eye on the production and the progress of our production. Okay, and WORKPLAN is keeping track of everything, and it doesn't need to be sheet metal operations. It could be anything. It could be assembly. It could be anything that you like. Okay, WORKPLAN can manage the time and cost implications. There's a few reasons why this is important. So if we work from a Radm schedule here, okay, I'll show you how WORKPLAN manages these nests, not only inside Radm, but also across the shop floor. Create the nests. Fantastic. Any remnants are managed as well. Okay, they're also put back into WORKPLAN just to be managed and accounted for. It helps with cost calculation. Now, when we run these, we can assign them and say, okay, this we can still change the sequence, for example. So in this case, we're picking up a nest. We can view it. We can have a look and see what parts are on there, which jobs are being covered by this particular nest. All the details are visible in there. We can print up a setup sheet or nest detail, even with a barcode on them. Okay. And then what happens is, now this could be on the shop floor, this could be in an office. We can put them ready to be started. So this for a particular machine tool and for a different machine tool, we can line them up, and that appears on the controller next to the machine as well. So they can see the sequence in which they're required or requested to run these jobs. Okay, this is how you can see the sequence. So this is for the Armada FOL, for example. You can leave extra instructions. Okay, for example, weld immediately or package carefully, things like that. Okay, and then we can specify that the job has been in progress. Okay, and we can see and monitor the realized time, the real time. And then when it's completed, it's not just a matter of saying that it's completed, but it's also confirming the real time that it's taken, and also whether there's any rejects. So the nest and the machine might have cut everything, but you might reject one of these parts. Okay, and the system needs to know. The nice thing about WORKPLAN is that it will immediately become an item to do in WORKPLAN. So we can see constantly what happens. So that was within WORKPLAN, but this is a screen next to the machine where we can see what nests we have to do today. So there they are, P20 and P22. They're for my machine, the FOL. Okay, and I can specify. That I'm now going to start or find a particular one. Scanning a barcode is always quicker, obviously. You can see the instructions that we just added. And then we can feedback. And this is a screen that you would typically find next to the machine. So on a tablet or a touch screen. Okay. Now, wherever that happens, wherever the user says that the nest is completed, it's automatically updated inside WORKPLAN. So whoever looks at it during the company, in the company, can see immediately which nest has now been finished, how long it took, And then also that gives you information about how long it took to cut the parts, or even just the status of the parts. So if your customer phones up, you know immediately. You can tell them, so, well, okay, we've cut 50% of them. You should be okay for 4 o'clock, for example. So WORKPLAN can also manage your inspection process. Okay, there's a quality management system inside WORKPLAN that can manage your results, your feedback, any issues, any rework and remake, and quality indicators inside WORKPLAN. And get everything ready for dispatch. This, for example, this is for shop floor operator. He automatically calculates, so who is it, how long it's been working on this, etc. He checks the job and checks and verifies that everything is in order. At every stage, whether that's the cutting or the bending process, any operator who's responsible for a certain job can specify how many were made or how many were scrapped. Any quantity and any progress is automatically always constantly updated inside WORKPLAN. There we go. Go back to WORKPLAN. You can see that there's been one part that has been rejected. So when you're satisfied that everything's there, everything fits and everything's put together properly, you can print the delivery note to go with the package. Everything's logged. You can send the email straight from in WORKPLAN. You saw that I don't even have to type in an email address. We know who to send this to, this invoice, this delivery note. Easy as that. So WORKPLAN also issues the invoice if you want to. Okay, it can calculate and keep track of all the invoices that you've got outstanding, etc. Okay, still our hopper and tower. When we started off at the back of this journey, hope you remember. Now, what also happens in WORKPLAN, that's quite a useful feature, is that you get feedback about how you actually did on this job. Okay, so how long did it take? How much material did we use? Because you might have made a few scrap parts and it breaks down exactly how much you've actually made on this particular job, time-wise, material-wise, the real income, and compares that to your targets. So what you can do with that information is maybe adjust your quoting strategy in the first place. Okay, so it tracks everything, and that's all for good reasons. Now at the end, we can print and send our invoice to the customer and track whether that's been managed. The nice thing again about WORKPLAN is any employee can see this information. They can see the progress, they can see the real value that's been generated, they can see whether the customer has been sent an invoice or not. Everything's visible in one system. Nothing escapes the process. So there's no more asking whether has anybody sent the email yet with the invoice. No. We can see who sent it, we can see who sent what time they sent it, etc. So we know exactly what's happened all the time. So that's the complete workflow from initial inquiry. I hope you remember all that way back where we got an email from a customer with a 3D assembly. We analyzed it, we prepared it for production, we planned it in, we scheduled, we nested, we cut, we invoiced right at the end. Now the products that you've seen, the product portfolio that you've seen that we use to do this, first of all, WORKPLAN, that's the big umbrella, so to speak, that keeps track of everything that we do and need to do. Then we use Designer to make sure that we do everything as optimized as possible, yeah, that we get the best parts out to the customer. We use RadQuote to estimate the costs and calculate the price and work on with the customer to gain the order. We then use Radband to prove that we can bend the parts before we cut any prototypes or disturb the press brake operator with this work. We use Radcombi and Radnest for the cutting and nesting operations for flat sheet metal. Now I said Radcombi here, but it includes Radpunch and Radprofile. It depends on what type of machine you have. We use Radcombi machines for customers that have a combination machine, so laser punch, or that have two different machines, laser and punching. So that's why I use Radcombi here. And Radnest is the engine that makes sure that we get enough parts or the maximum number of parts out of our raw material. And then Radm-ax and Radtube. Radtube is the tube cutting software. And Radm-ax we haven't actually covered here so much. It's more for 5-axis laser cutting parts. Okay, that's a small segment of our market, but tube is very common, becoming very common in where we are. So just to finish off with, there's a few, you find these on our website as well, there's a few good examples of who we work for. For example, one of the customers here is Shine Food Machinery. They do stainless steel kitchens and not little ones either. They have huge projects for hospitals, schools, colleges. You can see some of the images here. And all these panels, all the fascias that you see are stainless steel. They need to be designed, unfolded and cut all the right way up. And that was the big challenge here. And we automated some of their work to do this. This is actually a couple of years ago. This was for the Olympic Village in London when the Olympics were there. We did some architectural work. Okay, this is quite a challenging program. Huge panels, as you can see, with the little man holding them. He's actually full size. It's not that, but 11 holes, 1100 holes in each panel in a pattern that the designer had calculated. Different hole types, etc. So we automated, and this pattern was 200 times per panel. I don't know how many panels we cut in the end, but it was huge job, and we slashed their programming time in half, by a third. Okay, here's a good customer that uses the entire workflow, includes WORKPLAN in his operations, just to streamline everything that goes through their company. High-tech fabricators, and then HV Wooding. This is for quoting mainly what they use it for. You can see top right, the copper bars, they come in so many different sizes and lengths, and copper is expensive. So they wanted something that can quote accurately and consistently, but was also really quick and flexible, because there's no two copper bars that are the same for them. So that was the big advantage here. And the better you nest with copper, that's easy money to make. Another Alpha Manufacturing. They actually have a combination of our products. They use the punching and the laser cutting in very automated cells. They make nice looking products for the insides of fans here. And this one is a joint customer with Hexagon Measuring Arms, EdgeCam, and Radon in use. And the big advantage that we offered them was the material optimization, to keep the waste to an absolute minimum. So the key benefits that we're aiming for is that we keep trying to optimize and make the workflow seamless for you, so that where we get good information exchange and a short learning curve. One of our biggest hitters is the material utilization. We claim, and we've proven many times, that we have the best nesting engine in the world in this market. The optimization of manufacturing cycle time, we make sure that we cut reliably and fast on your machine. Make the most of your machine time as much as possible, as goes for the other resources. Okay, we try to make sure that your project costs go down and stay down, and keep your quality on control. And in the end, hopefully everything will be faster to market, on time, delivered to the customer to their satisfaction. So that was all I wanted to show you today. Now what I'm going to try and see if there's any questions in the chat and see if I can find an answer. There's lots of people shouting that my sound was gone. That's good. Does WORKPLAN handshake with any other ERP systems, or is it mainly a replacement? We don't actually pretend to be an ERP system replacement. We just take what we call the manufacturing execution system over. We don't do finance. We don't do your tax return, for example. So for that, we do link with ERP systems and leave that up to them. But we take over the manufacturing.